All right, we'll try to keep it under 10 minutes. I'm just going to talk a little bit about how I've chosen to use logarithms in my class to solve problems dealing with exponentials without directly accessing properties of logarithms. Here's how I start it with my kids. They know what an exponential function is, and they've certainly come across numerous functions that they haven't been able to algebraically find answers to, or equations that they couldn't find answers to. So we're now to the point where here's an equation. You can't find an answer to it unless you use your graphing calculator and your table or your graph. So here we go. I start them off with just something like 4 to the x is 4 to the 5th. And all I'm trying to do is establish that, hey, that's pretty easy when the bases are the same. So even if you make it something like, 4 to the x plus 9 equals 4 to the 13th, it might look intimidating to students, but they relax and they say, no big deal, x is 4. Even if we go 5 to the 3x minus 1 equals 5 to the, let's go, 14th. And the kids just say, hey, as long as we just need to make those two things the same. And it's kind of a no-brainer for them, but just trying to get them in the mindset of, wow, when those bases are the same, this isn't bad at all. And once I see that they see that, I really don't give them much practice with it. It's just a few problems on the board, and we quickly talk about it. And I don't waste much time until I get them to this. Let's say 7 to the x equals, 29. And all I'm looking for them to do is say, wow, those problems are different. That's a lot harder. That's the only connection I'm trying to get them to make there is it was easy and now it's difficult. And from there we can talk about some strategies on how would you formulate a guess. It's always fun to play that game of, well, what two whole numbers is will the answer be between? Just kind of some good number sense stuff for kids. So kids will say, oh, the answer has to be between 1 and 2, and you can also do some work here, and students can use their calculators and look at, use a graph, and let's say they graphed y equals 7 to the x and y equals 29 on their calculator, and they found that intersection point. So that's a good discussion to have now, but I've probably already said too much. My main goal here was just to say that, hey, you gave us a few problems that were really easy, and now you gave us one that we can recognize is different, and we're not able to find the solution yet. And here's another one that's different. 7 to the x equals, let's say, 5 or 4 to the 5th. Once again, students see that and they say, oh, that's not that type of problem where I could easily get an answer. That's different. So just setting up the need. Like, oh, kids, it'd be nice if we had a tool to help us. And from there, the tool that we're going to investigate is something they've got on their calculator. So they've got this log key. So then what I've had the students do at that point is, what does that key do? So you can spend some time investigating, or you cannot. Maybe you just tell them what the key does, but you want to get the students to a point where they understand what the log key does. So they put an input into the log function, they hit enter, and they're going to get something out. So we're really trying to show students, hey, let's if I go log of 27, you're like, hey kids, what does that mean? What's that telling you? And you want to, I think you want to get students to the point where they say, hey, that log 27, that is the exponent that you put on 10 to make 27. Right? So kids can do a quick estimation. The exponent I put on 10 to make 27. The exponent I would put on 10 to make 27. You say, hey, estimate, what do you think it'll be? Well, I think it'll be between 1 and 2, because if you put 1 on 10, 10 to the first is 10. If you put 2 on there, 10 squared is 100. So log 27 has got to be between 1 and 2. I got my calculator here. Log 27 is approximately 1.431. So, and students, I don't think they're yet going to see the connection between you started us with problems that were easy, then you gave us some that were hard, and now you've shown us this tool on our calculator. And I haven't had students put that all together right away and say, oh, now I can solve those. But it's just kind of in steps. So here are problems that are easy above. Then you made them hard. I can't get the answer. Now I've got a tool, and it's kind of weird, but what this tool does is I give it a number, and it's going to tell me the exponent I put on 10 to make that number. So let me go back to some problems. So let's say you'd give your kiddos, let's say 4 to the x equals, I don't know, 10 to the 4th. And so, students can go to a graph, they can go to a table to answer it, but right away the students realize that's not like the first set of problems you gave us. That's one of those that's more difficult. But if they can make the connection between what you just did above, I gave you a tool to convert any number to base 10, right? So is there a way to rewrite 4? 4 is 10 to some power. So let's say, I'm going to grab my calculator. Log of 4 equals, or is approximately, log 4.602. Okay, so 10 to the 0.602. That's 4. That's 4. Now, we had 4 to the x, so we have 10 to the 0.602 now to the x, right? The 10 to the 0.602 replaced 4. And that equals 10 to the 4th. Okay, and so students are like, okay, my life's really not any easier yet, but you might have to take a second right now and kind of review some properties of exponents, because students are going to wonder, well, that's fine and dandy, but how do I go about combining those? Like, I have 2 exponents. What are those rules again on how I combine those? And we're hoping to get students to the point where they say, oh yeah, I can certainly combine those. I remember the rules. I need to multiply those 2 things. So 10 to the 0.602x equals 10 to the 4th. And then the students all breathe a sigh of relief, and they say, that's like problems we did before, that first set. They're easier. So then they just set up the equation. 0.602 x needs to equal 4 in order for these 2 things to be equal. So they can solve that. So no properties of logarithms yet. It's not like we started this thing out and said, hey, go ahead and take the log of both sides and whatnot. So let's do another problem. Let's say, 5 to the 3rd equals 6 to the x plus 1. Students right away, oh, that's the harder type of problem. Okay, well, we have a tool. We're going to use that tool on the 5 and on the 6. So I'm going to go log of 5 is approximately something. Log of 6 is approximately something. So log of 5 is approximately 0.699. Log of 6, 0.778 about. And you really don't want students to forget, why did I do that? Okay, so I think it's helpful to say, so 5, back up, 10 to the 0.699 is approximately what? 5. 10 to the 0.778 is approximately 6. So this is another way to write 6. This is another way to write 5. So we're going to use that, right? We're gonna kind of substitute those things in. So instead of 5 to the third, we'll still have something to the third, and we'll still have something to the x plus 1. So instead of 5, we have 10 to the 0.699. Instead of 6, we have 10 to the 0.778. Now, students will get in trouble here when they start to look at combining these two exponents. They're not gonna want to see the distributive property. That's certainly something you have to remind them of. This one here isn't so bad, when you ask them, how do you combine these two exponents? So you can go ahead and finish this problem. 3 times 0.699 is about 2.0097. So that's 10 to that power equals 10. You can do this a couple different ways. I'm going to go ahead and just distribute that 0.778. So 0.778x plus 0.778. Hopefully at this point, kids will say, okay, if the left side equals the right side, they're both in base 10. Those exponents have to be equal. And the kiddos will go ahead and just set up an equation. I've seen a lot of kids in the past just say, okay, now when I get to that point, right, like, oops, this doesn't matter anymore, right? I've just got those two things there are equal, and they go ahead and they solve it. Okay, last problem. This is a fun one, and I think there's some good things in here for kids. We'll make one up. Let's go 13 to the x plus 2 equals 7 to the 5th. So I like to get up, you do this one with class, and all of a sudden, oh my gosh, I don't have my calculator. Well, that's okay, So kids are going to say, well, we need to know, let's take 13 and rewrite it as base 10. 13 is 10 to some power. 10 to some power equals 13. 10 to some power is 7. And you're like, oh, what is it? Oh, I don't have my calculator. So if I don't have my calculator, what should I put there? And it's not a stretch for students to say, well, you know what, that is just that's the log of 13. And over here, that would be the log of 7. Right? That's what we were going to try to do in our calculator. I type in log 13 and I hit enter. So, hey, no big deal. We don't have it. Let's see what happens if we continue working with this problem. So 13 is 10 to the log 13. Right, so that's what we got in purple up there. Right. So those two things. And that had an exponent on it. Its exponent was x plus 2. Okay, so that thing there is raised to the x plus 2. Okay, next on the right-hand side we had 7, but we rewrote 7. 7 is now 10 to the log 7. And its exponent was a 5. So this thing is going to be raised to the 5th power. Okay. So we can do this. Right? Students can do this, right? I mean, they might see log 13 and say, oh, that looks difficult. But it's just a number. You just remind them, if you had your calculator, you'd have a decimal there, but we just don't have one. So we reinforce that idea, hey, how do we combine these exponents? And the kids say multiply. How do we combine these exponents? And the kids say multiply. You want to make sure that they see the distributive property there. That'll give them some trouble. So we have 10 to the log 13 times x plus 2 equals 10 to the log 7 times 5. And now it's back to that initial problem set. Kids know I can answer that type of problem. These two things have to be equal. All right? So if you wanted them to grab their calculator and approximate it now, that's great. But they're at the right point. Right? They know that log 13 is a number. They know that log 7 is a number. And they can go through and solve that. And they haven't used any properties of logarithms. They're smart enough to say, I don't need that. I don't need that. Okay, I can solve that. Just make sure that they if they're going to use the distributive property here, great. If they want to divide both sides by log 13 to start, that's great too. So x plus 2 equals log 7 times 5 divided by log 13, and we'll just move the 2 over, and we're done. I think that's a great answer. So we solved a pretty difficult problem. We didn't use properties of logarithms. All the kids started with was, here are some easy problems, here are some difficult problems, here is a tool. And I'll have another video to follow this that kind of captures where I went next with the kids and using natural log, and then also actually looking at some of the properties of logarithms with these same concepts. Because once students were able to use this idea, then when it actually came to some of those properties and showing kids where they came from, it wasn't so bad. Thanks a bunch. I hope you found it helpful.